Chapter 15, Segment 3, Genetic Variation in Bitter. A chemist named Arthur Fox discovered that we do not all live in the same taste world. A non-taster is an individual born with two recessive alleles for the TAS2R38 gene and unable to taste the compounds phenylethylcarbamide and propionthiouracil. A taster is an individual born with one or both dominant alleles for the TAS2R3A gene and are able to taste the compounds phenylethylcarbamide and propionthiouracil. Family studies eventually confirmed that taster status is an inherited trait. The distribution of thresholds was bimodal, with non-tasters showing very high thresholds and tasters showing low thresholds. Women had lower thresholds than men, and Asians had lower thresholds than Caucasians. Fisher suggested that tasters were more finicky eaters because bitter tastes are more intense to these individuals. They tend to dislike foods high in compound, such as many vegetables, that non-tasters find more palatable. Also related to tasters are weight and health. Alcoholics and smokers were found to contain a lower proportion of tasters than would be expected by chance, because unpleasant sensations produced by alcohol beverages and tobacco act as deterrents. Dennis and his colleagues discovered the location of the gene that expresses phenylethylcarbamide and propionthiouracil receptors. This gene is a member of the bitter family introduced earlier and is designated TAS2R38. Supertasters, instead of measuring thresholds, the dimmest sensation, investigators could look at suprathreshold taste and plot the psychophysical functions showing how perceived taste intensity varies with concentration. Stevens' power law is S equals AL to the B power. S is sensation, I is stimulus intensity, B takes on different values for different sensory modalities. The value of B for bitter is smaller than the value for B for sweet. Cross-modality matching is the ability to match the intensities of sensations that come from different sensory modalities. This ability enables insight into sensory differences. For example, a listener might adjust the brightness of a light until it matches the loudness of a tone. This led to the discovery of supertasters. Tasters proved to be heterogeneous. Supertaster is an individual whose perception of taste sensation is the most intense. A variety of factors may contribute to this heightened perception. Among the most important is the density of fungiform papillae. Medium tasters match propionthiouracil to weaker stimuli, such as the smell of frying bacon. A propionthiouracil non-taster may be a supertaster for other tastes, but can never be a supertaster. Those with the most numerous fungiform papillae experience not only the most intense taste sensation in general, but also the most intense sensation of oral burn and oral touch. Because fungiform papillae are innervated by nerve fibers that convey burn and touch sensations as well as those that convey taste sensation. Health consequence of taste sensation. Some vegetables produce unpleasant sensations to a medium taster and supertasters, leading these individuals to eat fewer of them. Reduced vegetable intake is in turn a risk for colon cancer. Fats can produce unpleasantly intense sensations in supertasters, leading them to eat fewer high-fat foods and thereby lowering their risk of cardiovascular disease. The pathways of the taste nerves from the tongue to the brain are vulnerable to damage. The chorda tympani taste nerve passes through the middle ear, where it is vulnerable to middle ear infection. Omnivore's dilemma. Taste receptors detect specific features of molecules. Each of the four basic tastes is responsible for evolved according to its purpose. For example, the bitter taste subsystem is nature's poison detector. The other two taste subsystems enable us to detect and therefore selectively ingest foods that our body needs: sodium, which are salty, and sugar, sweet. In babies, sweet evoked smile like expressions by sucking, and sour produce pursing of the lips. Specific hunger theory is the idea that deficiencies of a given nutrient produces craving for the nutrient. Kurt Richter first proposed this theory and demonstrated that craving for salty or sweet are associated with deficiencies in those substances. However, the idea was proved wrong for other nutrients. Sensory specific satiety: eating a variety of foods because getting bored of a single food. The association of negative or positive effect with an experience is called evaluative conditioning. Research has suggested that very young human children are neutral to odors that attract or repel adults. We regulate our intake through a combination of hardwired basic taste and learned responses to food flavors.